Hi, this is Mrs. Kidman, and in this video, we're going to be discussing probability. So we're going to look at a couple parts of probability, but a reminder, probability of an event occurring is the chance of that event over the total number of outcomes. So let's do some practice with finding probability. So we're rolling a six-sided die. So with that total number of outcomes, in the previous video, we talked about how we can find that total number of outcomes by listing all the possibilities or by calculating it by asking how many options do I have. So then rolling a six-sided die, I have six options. We can either get 1, 2, 3, 4, 5, or 6. Now, because there are only 6 options, it's easy to list them. We don't always have to do that, but sometimes it can help. So the probability that we roll a 1, that's what this notation here means. The probability we roll a 1 is going to be a 1 out of 6. The probability we roll a 2 or a 3 is going to be 2 out of 6. Now, whenever we see the word or, what I want you to clue in is that we are going to add there. The reason why is because the probability of getting a 2 is 1 out of 6, plus the probability of getting a 3 is a 1 out of 6. Now, those are mutually exclusive, which means they cannot occur at the same time. So because they can't occur at the same time, we can add those together and say that we get a 2 out of 6. Now, what's the probability we get a number less than 3? There's only 2 numbers here less than 3, so it's a 2 out of 6. And we can simplify these down into 1/3 or into decimals, but I like to just leave them as they are. What's the probability of getting something greater than 3? Well, that's going to be 3 out of 6, or 1/2, because we've got 4, 5, and 6. Now notice how grateful I was to have all of our options listed, because I could count and I could look at my different outcomes. If having all your outcomes listed is not always an option, then you will have to kind of process through and observe patterns to see what happens. So with that being said, along with typical probabilities, we also have something called the probability of the complement of an event. So the probability of a complement is kind of the opposite. So what it would be is, instead of saying what's the probability that you roll a 1, which is 1 out of 6, the complement to that would be, what's the probability that you do not roll a 1? So let me write that again. Probability that you do not roll a 1. Well, we can figure that out 2 ways. One way that people will do it is they'll look at all of the outcomes and they'll count them, which works every time. But the probability of a complement means that for whatever the complement is, so not rolling a 1, we can do 1 minus the probability of the opposite of that event. So 1 minus the probability of our opposite. So what's the opposite of not rolling a 1? Well, it's rolling a 1. So we could do 1 minus the probability of rolling a 1, which is 5 out of 6. Now that's super helpful when we're trying to find this complement to our probability. Now remember, this can only happen if that event is mutually exclusive, so it doesn't have any other overlap. But probability of the complement is so helpful, because then we don't have to count everything. We can just use the opposite. So let's practice finding that probability. So we're rolling 2 six-sided dice. Up above, I've listed out all the options for you. Total, we have 36 options. So what's the probability that we get the same numbers? Well, I can look and see 1, 2, 3, 4, 5, 6 have the same numbers. So that's a 6 out of 36, or 1 out of 6. What's the probability they're not the same? Well, I have 2 options here. I can either count every single number that's not the same, or I can do 1 minus the probability that they are the same, which is 1 out of 6. And I can say I have a 5 out of 6 chance that my dice aren't going to be the same. Now, we also have questions like, what is the probability of the sum being greater than 7? Well, in this case, I'm going to count. The number that I have that's greater than 7 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 out of 36. Now the sum is less than 7. A really common mistake is people think that these two are opposites, but they're not. Notice how less than 7 and greater than 7, neither of them include that they actually add to 7. So those are not opposites, not opposites. And so make sure that you're not treating them as such. So to find the sum that's less than 7, we, again, in this case, just have to count it. And as we count all of our options here, we're going to end up getting that it is 15 out of 36 as well. And that makes sense because we have 6 that add to 7. So that means of the rest, half are greater and half are less, because 7 is the middle. So that is how we would do probability. Again, probability is the chance of an event over the total number of outcomes. Please check out the next video in which we discuss theoretical versus experimental probabilities and how that actually varies between questions, how that will actually vary in our results.